Mm, okay. So, good evening, everybody. Before starting, let me confirm my sound is okay. My sound is okay to everybody, and everyone understand. Everybody understands me. Okay. Now I'm going to introduce myself. My name is Muhammad Hilal, and I've graduated in marine science, and right now I'm pursuing a degree of master's in the same field. And recently, I have done my research during fourth year, and the title of my research, Temporal Trends in Shoreline Dynamics with Forecasting and Coastal Vulnerability Assessment of Kuakata Area, Bangladesh. Basically, it works with sedimentation, degradation, and forecasting, coastal vulnerability assessment. So, already we have, as we are research of ocean and everybody works with ocean, so we know more or less about shoreline. So I'm not going to touch in details and just I say the shorelines are dynamics, and there's a lot of reasons. And if you say one statement is human activities, but the human activities include a lot of things, and second of all, the natural factors. The natural factors could be sea level rise, could be wave action and cyclones and sediment supply, seasonal activities, and even tide range, gravity. So a lot of things we see. A lot of factors affect shoreline position, and they are not stable because of both natural and human factors. Bangladesh 29,000 square kilometer coastal zone, part of the Ganges Brahmaputra Delta, faces acute threats from sea level rise, erosion, cyclones, and saltwater intrusion. Basically, this study examines over 30 years from 1991 to 2021 um, of Kuakata area or Kuakata seabeach, and it focuses on sedimentation and degradation, focusing and trying to emphasize or emphasize needing of sustainable coastal management, uh, this research helps us to understand the reasons and to adapt to climate strategies. It helps to bring the climate adaptation strategies. And this study exam integrates imagery, tide data, and GIS-based analysis to quantify erosion, accretion, and land change. So look at so now move on methodology. Methodology, here we trying to bring some latest methodology methods to follow to be precise my resource, and this is my study area, and this is the Kuakata sea beach. And this is the schematic flowchart of overall approaches for this research. First of all, we can have data from different sources, satellite image basically, and we can find from USGS, CSA. USGS basically provide Landsat 5, Landsat 8, and Landsat 7. Even sometimes Landsat 4, actually, I needed basically Landsat 8 and Landsat 7. And ESA, European Space Agency, they provide 15-meter resolution. 30-meter resolution is used to provide an ESA 10-meter resolution of Sentinel imagery. And yeah, Sentinel imagery 1 and Sentinel imagery 2. And then we have to choose ArcGIS, QGIS. Even we can choose Google Earth Engine. As you know, I have gathered the skill of Google Earth Engine recently, but we can continue this research by using ArcGIS and QGIS. So after importing ArcGIS, and first of all, you have to do some correction of image. Sometimes certain images they have shown no data values, and sometimes they high cloud range. So that we need to correct image, and probably we need to correct image. Even the most things, actually, we know the most I have selected very narrow range of clouds, but here's I have to do this NDWI, normalized difference water index, and it basically helps to discriminate water area and non-water features. When you have water and non-water features, then you can extract the shoreline. And after done with shoreline extraction, before shoreline extraction, then we have to choose another software. This is this software, this application. This application, and then statistical calculation, LRR, WLR, and NSM, EPR, etc. And accuracy assessment. And then expected shoreline position by using LRR. Now, it's time to talk about results. This result, actually my results divided into two parts, the long term and the short term. The long term means we calculated over 30 years from 1991 to 2021. And this one, and these findings is density of land change. I mean, my shoreline is probably the Kuakata beach divided into three parts: western part, and eastern part, and middle or mid part. So look at this graph actually. So we see the eastern part is a high density of change. The frequency of land change is high. There's probably reason it stuck with Golachiba estuary, and the western part is stuck with Andamani estuary, and they receive high amount of discharge of sediment from Ganges River, and that's why it can't be stable. It's a reason, and more than we can say, the eastern part, a lot of anthropogenic activities can happen because either Crab Island. In Crab Island, they can collect mud, they can destroy trees, even they can collect crabs. This could be the reason to be more fluctuated at eastern part. Okay, this is a short-term findings, and the short-term findings, this is the shoreline movement rate, the shoreline movement rate. I mean, if it's the highest accretion rate, approximate 36 meter per year, we show, Okay, let me explain what the short-term findings. Short-term findings, we divided 30 years into three periods. The first period, 1991 to 2000, and second period, 2000 to 2010, and third period, 2010 to 2021. So there's a three period, three shorelines. So we see the highest accretion rate, approximately 35 meter per year, which year? This is the EPR 2010 to 22, I mean last year. And then the rate, I mean, probably more than approximately 25 meter per year. This is a movement of landward. Which year it happens? It happens basically 1991 to 2000. Okay, let's move on the short-term findings, some other short-term findings. This is the area of land calculation and land loss. In total, we found 80 square kilometers and more than 4 square kilometers we found in accretion in total. So this is a graphical mapping, graphical visualization. So we see the accretion happens most eastern part, even though it is a very fluctuated area, even accretion and degradation both happens in this position. And this is the final findings. It's not a very, I mean, calculated finding. Basically, I just put the expected shoreline position, and we see this is a deep color red. This is expected shoreline position, but you know what? Here, some area eastern part, and this still shows the degradation, and this is we can consider as a critical area. And yeah, probably, fortunately, we can have land gaining middle parts. Mhm. Conclusion. To conclude my study, this study highlights the Kuakata shoreline vulnerability to natural and human-induced factors, emphasizing the need for erosion control and sustainable management by removal of us. Conclusion. Actually, the findings provide a foundation for informed coastal policy and climate adaptation strategies. But my suggestion for future research that they can analyze with high resolution data, even field validation and more hydrodynamic model they can bring to know the exact reason behind sedimentation and degradation. And that's all about from my side. Thank you so much.